Hi everyone, and welcome to yet another video called What the JIT in csharp.net. And today we're going to discuss three things really. So first of all, we're going to discuss loop cloning, what it is, how to apply it, how to optimize it, and certain other things. Well, second of all, while we're doing loop cloning, we're going to discuss what's valuable Hoising. And third of all, we're going to compare if statements to if expressions and check if they're equivalent. So let's jump right in. Let's start with the if statements versus if expressions. So I have a method here, which is empty right now, which will take a boolean and return an int value. And let's just say that if the boolean is true, let's return 1, otherwise let's return 0. So as you can see, what we're doing here in this assembly code, we're checking if this is true, and if it's true, then we're going to assign 1 and return. Otherwise, we're going to assign 0 and return. So let's now compare that to an if expressions, because people will often tell you that if statements are equivalent to if expressions, but that's not really exactly true. So let's check it out. So I have an if expression here. And if we're going to compile that and decompile that to assembly code, then what we're going to see is that the order of these checks is reversed. So first, here in this first one, in B1, we're checking if B is true. Here, at the other hand, we're checking if B is false. And then we're going to, return 1. Otherwise, we're going to return 0. So the order of these checks is reversed, which means that they're not really equivalent. And let's move on to yet another interesting bit that we have today. So let's move to, the primary thing that we're going to be talking about, which is loop cloning. So whenever I have a method, let's just rename this to M, and let's do a bunch of things. So let me have a method which has an array as an argument, and then two additional arguments, x and y. And what we're going to do is we're going to assign the computation of x plus y to each index of the array. So I have a for loop here, which checks if I is less than 100, because my array is going to be 100 elements. And what I'm going to do is in each index, like I said, I'm going to assign x plus y. And right now, an interesting thing happened, because what happened now is this loop here got cloned. But let's not jump into conclusions yet. Let's verify that this happens. Let's first of all find our loop here in this big assembly code, and then let's see what else interesting is here. So my loop is here, and I can verify that because what I'm seeing here is that I'm assigning a register to an index, and then I'm incrementing I, then I'm doing the check if I is less than 100, then I'm doing the jump, and I'm gonna start over. So an additional interesting thing happened here, because this computation got hoised. And what I mean by that, it got pushed out of this loop to some temporary variable here. And how can we verify that? So if this is our loop, we're spinning here, then as you can see, we're assigning to each array index the value from R10 register. And R10 is being set here, which means that R10 is loading R9, or R8 plus R9, which is x plus y. So what we're doing here is we're doing x plus y, assigning that to R10, and then we're just using R10 from now on, which is very good because we just optimized that. So as you can see, I have this loop, I have a bunch of checks, and if I scroll down, what you're gonna see is that we have another loop here, because this is our loop. So again, we're incrementing I, we're checking if it's less than 100, then we're gonna do the jump. That jump is going to land here, so this is my loop. It's a bit bigger, as you can see, because now we're doing a bounce check. And if it's out of bounds, then we're trying we need to throw this exception here. And as you can see, we're loading R8 plus R9 into R10 in each iteration of the loop, which is slow and unnecessary. So now let's try to figure this out, why this even happens. Why have two loops? So let's go here and check, because there needs to be a bunch of conditions which will lead to one loop or the other, and what are they, right? So the first condition is here. This will do a binary AND operation on the register RDX, which means effectively that we're checking if the length is 0. And we're gonna jump to that second loop, which is slow. Then what we're gonna do is we're gonna check if the length is less than 100. And if it's less than 100, then we're gonna jump to the slow version of this loop. But if these two conditions aren't met, then we're gonna go to the fast version of the loop. So let me show you what it looks as a generated code in C#. So I have the loop cloned version here. So it's pretty much this. So if array length is 0 or is less than 100, then we're gonna go to the slow version, which will do a bounce check in each iteration. And if these two aren't met, then I'm going to, hose my computation out of the loop. And I'm just going to assign in each iteration. There's going to be no bounce check here, and I'm going to return. That's it. So why do we need two versions? Because as you can probably tell by now, if the array length is less than 100, we're going to crash here, right? So that's not good. Because why would we need a loop which is slow and on top of that it crashes? Well, the reason is that if we have a loop and we're going to assign something to an array which we got from somewhere, someone else might have a try-catch somewhere else, and we're going to crash. Yes, that's true, but the program might not terminate and the array might still get used somewhere, and it might be beneficial that this computation actually computed some of the elements. And that's one of the reasons really why we just cannot do these optimizations, because we're not trusting this code, kind of. So probably that's why it's not being hoisted, because there's no point, because we're gonna crash, obviously. So that's one of the reasons. And if we're good to go, if there's not going to be any problems with this array, then we're just gonna go to the first version, which means that most of the time we're gonna go to the first version of this loop, which is good. Okay, so still you might think, well, why do I need that? Because I know that my array is never gonna crash, and I don't want to generate all of these checks and all of this code, because these are branches. Maybe it's going to slow me down a bit. So I would like to have a more compact version of this code without any checks. Well, it turns out that if your array is 100 elements and you don't need to do anything else, you just iterate all of the elements of the array, you just do a length. And we just generated a version which doesn't have any checks, aside from like checking the 0, if length is 0. But other than that, we don't have any special checks. Our computation will get hoisted out of the loop, and that's good, because we're gonna start from here, and this is our loop. So we're doing the computation once, and then we're gonna assign it. So that's really beneficial, that's really cool, and we solved the problem without having to resort to loop cloning. Of course, if the array, if we want, for example, wanted to have like first 10 elements or like half of the array, then we would have to go through that optimization technique, but that optimization technique is still pretty good because it is fast. All right, so let's do another trick. So if you want this version, this fast and optimized version, you need to be mindful of like certain optimization techniques that you might do yourself. So you don't have to, you just cannot be clever with it. And what I mean by that you cannot be clever. So let's just say that you're gonna plan to use this somewhere in this method. Let's just say that this is not the, not the end, but you have something else to do and that length is necessary, for example. So you might think that, okay, I'm gonna assign this to a local, and then I'm just gonna use that local because I'm gonna use that local elsewhere in this method, somewhere, down below. and that might be beneficial for me. But as you can see, we just generated a loop clone version plus extra checks that we have to do now. And we just, we have a not very compact version of the code now. So if you want to have the best possible version of the code, you don't, you cannot do these local assignments, because although we still know that this is not going to crash. Currently, in the current implementation, the JIT will, it cannot figure this out on its own, and that's why you're seeing these effects. So that's a problem. Okay, let's move to yet a different example. So let's just say that this array is a field in a class or a property in the class as well, because this often happens that we have a class, it has its data, and we have some methods and we're doing something with the data. So now if we're gonna do this experiment, we're gonna generate a slow version of this method, because what needs to happen here is we're doing a bunch of checks. First of all, we're checking if the length is 0. Then we're doing a bounce check, and let's verify that it's true, because this is our loop. We're going to do the jump to 13. So our loop effectively is this. So we're doing the bounce check here. Of course, our computation got hoist, and that's good. So that isn't a problem. But we're doing all of this work here. Maybe that's not really necessary for us. It's because the JIT cannot really determine if this can be optimized away, these checks, because this is global. It might be used by someone else, probably, who knows. So if you want to, skip these bounce checks and extra checks, then what you have to do is you have to assign this array to a local. So if we're gonna assign this to a local and change, every alias of A to L here, then we're gonna have a compact version again. So this is a really neat optimization trick. If you know that you have a global array, for example, in a class, then you just assign this to a local. And if you have a tight loop, then that may be beneficial to you, because you're going to do less checks. So that's a very interesting bit to do. And let me switch now to some performance tests. So what I have here on this slide, I have the loop clone version versus the non-loop clone version tests. And as you can see, it's slightly faster. It's not something that you can be like super excited about, but you can still tell that the loop version is faster, but there's a catch. The catch is that method has to be called, the loop clone version, all the time, or it has to be in a very tight loop in order to see these, to basically tell that the loop version without any cloning or optimization is better. But otherwise, they're pretty much the same. But if you have like a very tight loop that you want to optimize, that's still a thing to look at. It might be worthwhile. Same with this version. If you have something that needs to run as fast as possible, perhaps it would be good to copy this to a local. Okay, if you got value out of this video, like and subscribe. Leave a comment if there's some problems you see with this video, and perhaps leave a comment. Maybe there's something you want to see in the next video, so leave a comment as well. And that's all for this video. So see you next time, and thank you and bye.